World War II saw some of the fiercest naval encounters of the modern age. But by 1943, the role of the Allied navies was changing. Having won complete command of the seas, their jobs now were to support and supply. The war from here on would be fought on land and in the air. But the big gun battleship was about to enjoy a new lease on life. Developed to project power at sea, her huge guns had been progressively outreached by the potential of the aircraft carrier. But an amphibious assault, the means by which the coastal defenses of Germany, Italy, and Japan would now be breached, she had a job to do. And so she turned her guns on the land. This was a warship at its most fearsome, bombarding targets with repeated precision and devastating effect, visiting retribution from the sea. And in September 1945, when the war finally ended, and General Douglas MacArthur needed a symbol of military power, one the conquered enemy would understand, he chose one of his battleships. In Tokyo Bay, before the eyes of the world, USS Missouri was to be the surrender platform. No instrument of war spoke so forcefully of America's power as the big gun battleship, and Missouri was the biggest afloat. How the gun finally got to be greater than the ship is a story that begins with a wreck 40 fathoms down on the floor of the Atlantic. A sea battle fought between two ironclads in 1862 became the most memorable and significant naval encounter of the U.S. Civil War. The battle was fought to a draw, but when it was over, so was the age of the wooden warship. One of the ironclads had a feature of such historical importance, it is now being reclaimed from the ocean floor. The ship had only 2 guns, but they were mounted inside a revolving armored shield, the world's first gun turret. The ship was John Ericsson's revolutionary Monitor. Monitor was a steamship like no other. Ericsson designed her as a gun platform. To present the smallest possible target, he gave her a dangerously low freeboard, the distance between the ship's deck and the sea. In Monitor's case, the freeboard was a slender 13 inches. As a consequence, in a storm off Cape Hatteras in 1862, she failed to weather the high seas and went to the bottom with 16 of her crew. More than 200 feet down, Monitor lies where she sank 140 years ago. Her hull is rapidly eroding, so the rescue is a race against time.
There's no point cutting.
He was just right in where about there, just about directly over the port.
Seemed like right over the arm there was this beam of some sort of or pipe.
The Monitor changed everything about the way warships were designed and warships were built forever. The concept of a compact iron vessel that was no longer relied on having to turn her vessel, turn her ship broadside to fire one way or the other, was wholly unique in the history of the world.
Try 513, Dill.
Anything soft, pull it on.
Its only shortcoming, and it was really not a shortcoming of design, was that it was only good for inland waters. It was never intended to be an ocean-going vessel, and so when it was taken out to sea, it sank, and that's why we're investigating it now. But for its design purpose of inland and harbor defense, it was an excellent design, and in fact the gun turret is still one of the mainstays of the modern warship.
Ericsson's turret was based on a single massive spindle, a big axle in the center of the turret, and the entire axle would be lowered slightly when the turret was in position to fire, and that would lock it into place to allow the guns to have a steadier platform.
John Ericsson's monitor spawned many copies. The turret worked. It protected the gunners from the heat of battle. But its mechanism wasn't quite right. The enormous weight meant it took a long time to reposition. In Britain, a naval gunnery officer was working on a turret design that would prove more successful. The officer was Cowper Phipps Coles, and the only surviving example of his design is on this ship, the Huascar, at the Chilean naval base 300 miles south of Santiago. Ericsson had used a pivot to revolve his turret. Cole's inspiration came from a railroad turntable.
The key to this system, quite clearly, is the ability of the turret, as we see here, to rotate, to bring the guns to bear on the target as required. And of course, when you're not engaging the target, to bring the guns away from the target to be reloaded. You can see it here under the turret, the roller system which Coles developed from Brunel's original suggestion to mount the turret below the deck in a safe place so the rotating mechanism isn't in harm's way. Inside the turret, 2 heavy guns were mounted on slide carriages which use a combination of friction and gravity to slow the guns up as they recoil into the loading position at the rear of the turret.
Cowper Coles understood the problems of modern gun warfare and how to design for them, but he had little or no idea about ship design. He shared with Ericsson a belief that a shallow freeboard, the least distance between the deck and the sea, made for the best gun platform. Possibly true, but far from practical on a rolling ship in a high sea. And his confidence in this dangerous notion would pit him against Edward Reed, the most important naval architect of the day.
Reed was perhaps one of the most intelligent chief constructors that the Navy's ever had. He's a very artistic man, a novelist, a poet, and he understood the dynamics of ship design at this very difficult period for the ship designer when people were having to combine sails with steam and bring in armour, perhaps better than anyone else. In fact, there was probably no better expert on how a ship worked and what would keep a ship afloat.
Reed had already begun to make his mark with the introduction of a central iron box, or battery, to protect the vitals of the ship and provide a platform for the guns. The battery enabled him to build a battleship that could deal with the high seas.
Reed built a turret ship, the best one he could, Monarch. Coles said no, he could do much, much better.
Reed and Coles had never seen eye to eye. Reed, the professional ship designer, simply had no time for one-cause monomaniacs like Coles, who was presenting a weapons system, or indeed a weapons mounting system, as the answer to all the problems the Navy had.
And so the great battle between the two men developed and was resolved in an extraordinary way, where the Admiralty actually allowed Cowper Coles to have his own ship design built, the famous, maybe the notorious HMS Captain.
Edward Reed was far from happy with this arrangement.
The Admiralty was building a ship which he had not designed, which he had not certified, which he had not tested, and without seeking or indeed taking his opposition to the project on board.
In 1870, Reed resigned over the affair. But the drama was far from over.
The captain ended up proving that Cowper Coles was not much of a hand at designing ships. The turrets, logically displaced under a flying bridge, but the freeboard here was little more than 8 feet as designed and only 6.5 feet as completed, as the ship was rather heavier than intended.
The admirals had misgivings and wrote to the builders.
I am commanded by the Admiralty to call your attention to the fact that the stipulated draught of water at the captain has been exceeded by 22 inches at least, and that the qualities of this ship may be prejudicially affected by this error.
On a second cruise with the Channel Fleet, Cowper Coles was actually on board to witness the triumph of his masterpiece. And one dark night off Cape Finisterre, the ship was proceeding under sail with a fairly full set of canvas spread from these enormous masts when she was struck by a gale. The gale went through the fleet, breaking rigging, damaging masts, and breaking the yards from which the sails were hung. But in the case of Captain, the rig held up, and the gale simply blew the ship over onto her side. She filled and she sank, taking with her all but a handful of her crew. The incompatibility of the turret principle with low freeboard and these enormous masts destroyed the ship, her company, and her inventor. It was perhaps ironic but fortunate that Coles should go down with this ship and never be seen again.
The loss of the captain was a national tragedy, but it brought an emerging problem into sharp focus. Building a warship was the single most expensive project a government could undertake, yet much was left to chance in all new designs. Not until the ship was launched and tested could the design be deemed a success.
One of the key results of the Captain disaster was the removal of amateur influence from ship design. Reed had already established the scientific basis of modern ship design. It was then reinforced by the work of William Froude, who introduced hydrodynamic testing in a model tank.
William Froude had been brought in by Reed to work on his latest battleship. It was Froude's idea to make wax-scale models and to test them for performance, both at sea and in test tanks. This more scientific approach helped produce one of the milestone battleships.
Even before Captain entered service, Edward Reed decided the answer was to get rid of the masts and to build a pure steamship. And this, HMS Devastation, would be his masterpiece, entering service in the early 1870s with her turrets fore and aft, 2 25-ton guns in each, a pair of funnels for her steam engines, and a mast simply to carry signals and to indicate her nationality. But the turrets are mounted significantly higher than they were in the Captain. Reed developed the principle which he called the breastwork monitor, separating her from Ericsson's original by carrying the turrets further up in the ship so that the guns actually had a higher command and were less likely to be swamped by the sea.
With Devastation, launched in 1871, the modern battleship was beginning to emerge. And a year later, pressure from Reed on Froude's behalf resulted in the construction of the world's first marine test tank. Built in Torquay, England, it established a practice of marine hull testing that was quickly adopted worldwide and remains the principal means of predicting a ship's behavior at sea.
Froude's contribution allowed people to have much greater confidence in the design of ships. They could actually be tested in a realistic, measurable way under ideal conditions.
The modern warship was all but complete, but with one significant shortcoming: engine power. As guns got bigger, armor got thicker, and the warship got heavier. Bigger and bigger engines required more coal to cover shorter distances. The warship was heading for a technological impasse. The man to provide a breakthrough was a true genius of his age, Charles Parsons. Inspired by an ancient Greek device called the aeropile, he used a jet of high-pressured steam to spin an intricate set of propeller blades, thus creating a very high-speed engine, or turbine. Parsons successfully used his new engine to power electricity generators. But he had a bigger dream, to build the fastest ship on Earth. Parsons began work designing a yacht. No shipbuilder himself, he got others to do the building. But the means of propulsion would be his new turbine, so he named her Turbina. After a great deal of planning, she was finally ready for testing on the Tyne River. Parsons' turbine was a high-speed, high-powered engine, theoretically capable of high performance. But in test after test, it failed to live up to expectations.
When he installed his steam turbine, he was very disappointed because he couldn't achieve even 20 knots, whereas he was hoping to achieve 30 to 40 knots with the steam turbine.
Tests showed that this was nothing to do with the turbine, but it was the propeller that was at fault. And being bright, he then decided to try the propellers. And this showed that cavitation was the problem.
One of the real problems of the propeller, as engines got more powerful and whirled round more and more, was cavitation, effectively bubbles of steam being created by the force of the propeller turning in the water. When your cavitation is bad, the power no longer is put into the water, so it's counterproductive. You can have as powerful an engine as you want, but you can't transmit the power to the water. Solving the problems of cavitation was really as important as developing the engines themselves.
In pursuit of a solution, Parsons had invented the cavitation tunnel.
Okay, I think that looks nice. You're looking at a really, in my terminology, is a very nice full developed cavitation in terms of the tip vortex as well as the sheet vortex. You can see that the Parsons realized the density of the thrust or the power generated by the propeller shouldn't be that great. To prevent this problem, you simply introduce more blade area, if you like, to the propeller, or distribute the power into more than one shaft, if you like. So indeed, Parsons put 3 turbines and then transmitted the power to 3 shafts. Indeed, he went further, and each shaft he put 3 propellers. So tandem 3 propellers, he ended up with 9 propellers instead of one large big single propeller, but solving the problem.
Parsons' dream was about to become a reality. His next move was the most spectacular and the most controversial of his brilliant career. The year was 1897, and all the crowned heads of Europe were gathering off Portsmouth to celebrate Queen Victoria's Diamond Jubilee. The venue was the annual Fleet Review. All of a sudden, through the sea-borne ranks of royalty and heads of state, stormed the little Turbina. As she tore past the columns of cruisers and battleships, the Times reporter observed,
With deliberate disregard of authority, Turbina gave herself an advertisement by steaming at astonishing speed between the lines. The patrol boats, which attempted to check her adventurous and lawless proceeding, were distanced in a twinkling.
At almost 40 miles an hour, Parsons' Turbina was not just the fastest ship on Earth. She was just about the fastest thing on Earth. The Navy did not catch her. The reporter continued.
Her speed was astonishing, but accompanied by a rushing sound and a stream of flame as long as the funnel itself. Unless these serious defects can be corrected, the system of propulsion devised by Mr. Parsons cannot be applied to torpedo boats, for whose operations silence, secrecy, and invisibility are indispensable.
How wrong could one man be? The turbine changed the naval fleets of the world overnight. It would revolutionize torpedo boats, cruisers, destroyers, aircraft carriers, everything. USS Bunker Hill is a Ticonderoga-class cruiser with the United States Pacific Fleet.
Starting to off.
The engines are LM2500 gas turbine engines. It's a 16-stage compressor that turns at about 10,000 RPM, propels the ship through the water at speeds in excess of 30 knots. The turbine really hasn't changed in principle over the last century. There's been some mechanical changes that make it more maintenance-free, but the general principle is the same.
The turbine didn't only have the effect of driving the ship much faster through the water, it also allowed the ship to be made to a much more compact design, because the old piston engine had, of course, to have considerable clearance over the crank shaft for the pistons to go up and down. And the more powerful an engine you wanted, the greater the height of the rise and fall of the piston had to be. So battleships stood high out of the water if they had piston engines, and were therefore easier to hit. By introducing the turbine, you got the profile of the ship much lower. It made it a more difficult target for the enemy, and it also allowed you to distribute armour much more efficiently. And of course the saving in the weight of armour contributed to increasing the power of the ship. So it was altogether a much, much more efficient design.
The turbine found no greater champion in the British Navy than Admiral Sir John Fisher, commander of the Mediterranean Fleet and known to his officers and men alike as Jackie.
Well, Jackie Fisher was a most unusual naval officer. He looked oriental. He had a sort of rather feline, feminine face. He also had a sort of a mind of oriental subtlety, there's no doubt about that, allied to a very fierce will.
A charismatic leader, he loved to dance, and he loved his officers and men to dance. In popularity and style, Fisher was compared to his hero, the legendary Admiral Nelson. This was a fitting comparison because Fisher was about to inherit a navy that needed another great leader like Nelson.
He had an extremely intelligent and creative mind, and he saw that the Royal Navy was in urgent need of modernization, not just technically, but culturally as well. Fisher said it was ridiculous that in a navy which had said goodbye to sail 50 years before, and which was entirely dependent for its future on command of technology, that the engineers should be treated as an inferior class. So he introduced common education, so that at the initial point, engineers and seamen should be trained together. It didn't altogether work, but at least it was a beginning.
In the 1890s, the fleet was a ragtag collection of warships pieced together from a period of experimentation that would become known as the Age of Uncertainty. But advances had been made with the guns. As the armor got progressively thicker, newly developed slow-burning gunpowder, in combination with a much longer barrel, had increased the gun's range and power of penetration enormously. The breech loader had come of age. But in 1896, the British Navy was a navy grown complacent from years without combat. Fisher had the guns. What he needed next was the gunners.
DOI, Swick and the OD will also verify range clear or foul. Here, MSS Birdsway 8315.
And take Swick We don't have a visual on that track 8012.
Firing accuracy, or fire control, on Bunker Hill is not something a sailor from Fisher's Navy could begin to comprehend, even as science fiction.
Outrider Alpha, this is vertical swords and track bearing 178, 28 nautical miles, course 343, over.
PSCI, step 14 is complete, test is off, 15 complete, magazine is deauthorized. This is red.
We're getting ready to do a missile firing exercise. We'll have a target drone fly out past us, and we're going to shoot at our missile system.
Aft SMs are depermitted.
It's a supersonic target. It's going to come by us a couple of miles out, so it's going nearly as fast as the missile we're shooting at it. So you got to be on your toes and do everything just right, or it's gone in by before you know. But that's exactly the training that we need.
Drones away. Outrider Alpha, this is vertical swords, birds away, track 8304.
A direct hit. In 1899, Fisher's search for a top gun had produced a star, Captain Percy Scott. In shooting competitions introduced by Fisher, one crew consistently outgunned the rest. They were the men of the HMS Scylla, Scott's men, and they caused a sensation. Soon other gun crews in the fleet, inspired by their new hero, embarked on what would be remembered as a gunnery revolution.
Scott's gunnery revolution is not a single change. It's a continuous revolution, beginning with systems that allowed men to load and fire the guns more rapidly, then systems that allowed the sights to be kept on the target continuously despite the rolling of the ship.
The other thing Scott brought in was director firing. If you can actually operate all the guns from a single spot in the ship, a director at the top of the foremast, you can actually improve your capability to fire your big guns at once and accurately at long range.
Scott's gunnery systems, even the early ones, improved the rate of hitting at standard combat ranges from 25% to 90%. Were considered absolutely revolutionary and were copied all around the world with great success by the Japanese, the Americans. This was the ancestry of modern naval artillery.
The ability to use big guns accurately over huge distances was having an effect on global thinking about what sort of guns a new generation of warship might have.
Early steel battleships were what were called mixed caliber ships. That is, they had usually a relatively small battery of the heaviest caliber guns, say perhaps 12 or 13 inch, and an extensive battery of medium caliber or cruiser weight guns that were part of the ship's offensive armament. As fire control improved and as battle ranges opened up, this put an end to the usefulness of the intermediate battery. If we discard the cruiser weight battery and put all our eggs into the major caliber basket, this will have a number of different advantages. One, of course, is simplifies logistics. You only need one caliber of offensive armament, so there's only one caliber of ammunition required. It makes salvo spotting much more practical.
It rapidly became accepted throughout all the navies that the big guns, fired together in salvo, would be the best way to arm the new battleships.
The logic of what came to be called the all-big gun ship was it was driven by a revolutionary new engine, the turbine, but also the firepower of the ship was based upon the largest gun possible, but only that gun. Although many people contributed to it, it was Jackie Fisher who was the presiding genius and who said, "Don't argue, I don't want to hear about the difficulties. This is the ship of the future and we are going to build it."
Built in just a year and a day, this was a ship so definitive her name would be given to the entire class of battleships that would follow her. She was the HMS Dreadnought.
One of the most remarkable features of the early years of the 20th century is how a whole and highly expensive generation of reciprocating engined, mixed armament ships suddenly became totally obsolete and were replaced by the new ships of the Dreadnought era. It happened in a few years, and it must have driven treasuries out of their mind.
The age of uncertainty was over. Here was the age of absolute certainty. America, Germany, France, Italy, Japan, throughout a world hovering on the brink of war, the keels were laid for the new generation of warships.
The British simply pursued it with greater speed and efficiency than any of its competitors did, particularly Germany. So that in 1914, Britain did have more dreadnoughts than Germany had. Not many more, but just enough.
And with sickening inevitability, it happened. 1914 saw all of Europe mobilized for war. The battle lines were drawn. At sea, the British Navy stood alone between the Germans and the Atlantic. Britain had the most powerful fleet on Earth, but it was untested in war. If the Germans were to break the blockade, they would need to draw the British ships out into open water and force them to engage. It was a game of cat and mouse.
The British would have liked a fleet action. Their only hope was that the Germans would, of their own accord, mount a fleet sortie, where the Royal Navy, the Grand Fleet, would take them at a disadvantage, which is exactly what happened at Jutland, but not quite in the way the British expected.
The Battle of Jutland would be the showdown both sides sought, but in a way neither side had planned. May 31st, 1916 found the Germans steaming northwards off the coast of Denmark when they encountered a fleet of British battlecruisers. A vicious battle ensued and the British took severe punishment. But their commander, Admiral David Beatty, suddenly realizing that he had the entire German fleet at sea, turned to draw them onto the guns of the approaching British dreadnoughts. The German high seas fleet sailed towards a horizon that was bristling with guns. A little before 6:30, the British opened fire. And at a range of almost 7 miles, the first the Germans saw of the enemy was the muzzle flashes illuminating the skyline.
The Germans have only one choice in this contingency: run away, although it was technically called Gefechtskehrtwendung, battle turn away. And they do turn away, and they disappear off into the mist.
It's understandable that the Germans, as the weaker fleet, should have a special technique for turning away. We don't need it, because we will always be going towards the enemy.
Jellicoe proceeded to sail his dreadnoughts across the German line, hailing fire on them until Scheer's nerve cracked. Within minutes, he was forced to execute a defensive maneuver. Jellicoe set off in pursuit, but to his amazement, the Germans turned yet again onto the British guns. At 7 minutes, with the setting sun behind them, the Germans were sitting ducks. Badly mauled, Scheer ordered a second turnaway, while committing the German battlecruisers to a death ride, ordering them to charge the enemy and unleash waves of torpedoes. This time, Jellicoe was forced to retreat. Under cover of darkness, Scheer broke free of the Grand Fleet, while Jellicoe, fearing another torpedo attack, held off the chase until morning and lost his only chance to remove the German threat.
So the British have not succeeded in their objective of sinking the German High Sea Fleet. On the other hand, the Germans have succeeded in inflicting disproportionate attrition on the British fleet. And it's for that reason that some people say, perhaps on points, the Germans won. Now, in no sense did the Germans win in gaining any kind of command of the sea. The British were just as much in command of the seas outside the North Sea at the end of the battle as they had been at the start of the battle.
Nightfall not only robbed Jellicoe of his victory, it stole from the big gun battleships their one opportunity to prove their worth. One can only wonder what a few more hours would have made of Jutland. But the first great clash of the dreadnoughts was also to be the last. The Germans, relieved to have escaped annihilation, switched their strategy to U-boat attacks on commercial ships in the Atlantic. It was to prove a costly mistake. No longer were the Americans on the sidelines. Within a year, they were in the war. And with them came the new breed. USS Texas, launched in 1914, was the new generation of dreadnought. The most powerful warship afloat, with 10 14-inch guns mounted in 5 twin turrets, and a second battery of 18 5-inch guns for use against destroyer attack. Added to this were 4 torpedo tubes below the waterline. And in 1916, Texas was the first to acknowledge the emerging threat from the air, adding anti-aircraft guns and armor. As flagship of the fleet, her command and control center was heavily protected. Operations remained possible even under the most severe bombardment.
What we're in now is the armored conning tower. It's essentially a duplicate, equipment-wise, of what you would find on the main bridge where they would navigate the ship from. The development of the armored conning tower, as you're seeing it, really comes about in the area of the dreadnought, the second generation dreadnought, like the USS Texas. There's 12 inches of armor on top and on the sides. It's face-hardened, carburized armor. It'd take about 6 months to make each plate of this armor. And in this compartment here, you had main battery fire control. And as you see in here, the range and deflection indicators for the main batteries. Here you can see the attitude of the ship. And here, you've got the indicators for all 5 of the 14-inch turrets. And there would be an officer in here who would then indicate range deflection for the 14-inch guns, and indeed would fire the main battery right from here. In fact, though, captains rarely, if ever, commanded from these during battle conditions. They kind of wanted to be seen as accepting the same risks as their men.
Up to Jutland and after Jutland, the prevailing belief was that the dreadnoughts, the huge battleships, would determine the outcome of any battle, or even possibly determine the outcome of a war. For that reason, they continued building battleships. The United States did particularly. The British couldn't afford to do so after the end of World War I because the British were broke, were bankrupt.
Not just the British. The Great War had been a costly affair for all sides, and now the United States and Japan led a new arms race. The peace was proving expensive, and a line had to be drawn. On November 12, 1921, Washington opened the world's first arms limitation talks. The United States, Great Britain, Japan, France, and Italy all attended.
This massive 16-inch rifled naval gun was being built here in the Washington Navy Yard even as leaders from the naval powers of the world were meeting in 1922 for the Washington Naval Arms Conference to reconsider what should be the limits that might be placed on naval power all over the world. How might there be a rational limit to all of the spending?
Out of it came, of course, a disarmament plan. Various ships would be destroyed, no new ones would be built, not only battleships but others, and a kind of a ratio as far as various nations were concerned.
The Washington Treaty dealt a body blow to the big gun battleships. Many were abandoned, many more scrapped. At the stroke of a pen, the United States achieved parity with Great Britain, and having generally newer ships, stood poised to become the world's most powerful navy. But even as the treaty was being signed, the battleship was being dealt another, ultimately more lethal blow.
By way of experiment off the coast of the United States, an old battleship was subjected to air bombardment. After only 4 minutes of hits and near hits, she sank. The great armored ship had been shown to be more vulnerable than even experts believed.
A concerted campaign of public demonstrations, staged to prove the assault power of the airplane, served also to expose the battleship's vulnerability, even though it was unmanned, unarmed, and at anchor. That year, politics sank a lot of ships. A succession of agreements held for just over 10 years. But then the Japanese, followed by the Italians, began to build bigger warships. Germany then renounced the restrictions of the Versailles Treaty and laid the keels of the Gneisenau and the Scharnhorst. The dictator nations were off and running, and the democratic nations took note. The race was on again. The reason would soon be all too obvious. In 1939, war raged through Europe. America could only watch and wait as once again navies were mobilized against each other. The battleship, still widely considered to be the most potent and flexible weapon of modern warfare, was at the heart of the European fleets. The heart of the U.S. Navy's Pacific Fleet was thousands of miles away. On the morning of Sunday, December 7th, 1941, all but one of the U.S. Pacific Fleet dreadnoughts were lying at anchor in their home base of Pearl Harbor.
I came on watch at 4 o'clock that morning. Came back from Liberty and went on watch. So at 5:30, I sounded reveille to get everybody up.
"200 miles to the north, 6 Japanese aircraft carriers were turning their bows into the prevailing wind.
And then at around 6, I sounded chow call so that they could get up there and eat.
At 6 o'clock, the Japanese launched their first wave of attack. Torpedo bombers, high-level bombers, and fighters all headed south.
And then I had breakfast and I went back on the quarterdeck. And then about 5 minutes to 8, I sounded first call for colors. And about that time, that's when we saw the bunch of airplanes coming in.
When airplanes were heard, a little before 8 o'clock that Sunday morning, no one was alarmed. There was no reason to think they might be hostile.
From a distance, you can't tell whether they're yours or who they were. And at this time, we weren't at war with anybody that I knew of. And so we said, well, it's going to be a drill.
But it was not a drill.
General quarters sounded and I went topside to my battle station. There was no need for radio communication. It was obvious we were under attack. Planes were all over the place.
The first attack launched a torpedo against the battleship California. It was a direct hit.
Our first sergeant came up because it blew him out of his office and says, "Get your butts to your battle stations, we're under attack." And I said, "Who?" He said, "The Japanese. Get your head up there."
After the torpedoes, the bombers took their turn.
I had my right ankle shot open. I had a chip of bone out of my right shin. I had my right hand shot open. I had 5 pieces of shrapnel in the left leg. Oh, I had something go through the right thigh and out my rear. I had a 6 by 8 inch piece knocked out of my left thigh. I lost part of my left elbow, part of the left bicep. I lost all the skin from my face, arms, legs.
Arizona took a direct hit.
I have never in my life known fear like that moment. The explosion was just tremendous. The bow just seemed to come up and settle, and then this hellacious ball of fire, and it was over. And that's all it was. We fought fires up until about 8:45, and then someone said abandon ship, and I didn't argue. I went up forward, dove over the side, and swam to Fort Island.
This is CBS in America calling Honolulu. Go ahead, Honolulu. This is CBS in America calling Honolulu. Go ahead, Honolulu.
In less than 2 hours, 18 ships of the Pacific Fleet had been crippled or sunk, including the 8 battleships. The Arizona and the Utah remain where they fell. Poignant reminders of that day of infamy.
Go ahead, Honolulu.
What it demonstrated was simply that the aircraft carrier had come of age as a weapon. Pearl Harbor showed that there were some very high-performance carrier airplanes around that could really pack a very serious punch.
The battleships had been sitting ducks. This had not been a battle fought on their terms. But nonetheless, their power had been eclipsed by a superior force.
The lesson of World War II was that the battleship, the great ship of the line, which was in the same lineage as Nelson's Victory, had seen the end of its day, and an entirely new technology had appeared to replace it.
Until World War II, the battleship was the ship that had shaped history. Her command of the seas was won by sheer power. Power of speed, of endurance, and above all, of firepower. an ability to give and take punishment in equal measure. Naval thinking throughout the early part of the 20th century had been dominated by lessons the battleship had taught 100 years earlier.
Through the 19th century, the British had established control of the world seas without clearly formulating a national policy of exactly what they were doing. And curiously enough, it turned out to be an American who finally explained to them, in retrospect, what they had done. An American naval officer, Alfred Thayer Mahan, started to believe not that naval warfare is decisive, but that it can have an enormous influence on the outcome of that conflict. And it was he who first saw that in order to achieve your military objectives at sea, you want to have what he called command of the sea. And Mahan believed that the way the British won command of the sea was to bring the enemy to bear in a decisive engagement between the main battle fleet. And when you had defeated the enemy fleet in that decisive engagement, then you were free to use the sea however you wanted, and he believed that would help shape the course of history on land. Ironically, he convinced most of the world's great maritime nations to adopt his view of sea power at just the time the technology was undermining the historical model he'd used. His model fit perfectly what had happened in the great age of sail. But now there were new technologies around that were calling into question the hierarchy of power, the invulnerability of the ship of the line.
The site where more than 1,100 men lie entombed in the USS Arizona is a somber but fitting place to end the story of the battleship. For it is here, if anywhere, that the dream of the big gun battleship as the ultimate warrior began to die. Her big guns would be needed as the war turned and the enemy was driven back. She served honorably in Korea, Vietnam, and the Persian Gulf. But from that fateful Sunday morning in Pearl Harbor, the days of the dreadnought were numbered.
Warship was made possible by the Alfred P. Sloan Foundation to enhance public understanding of the role of technology. The foundation also seeks to portray the lives of the men and women engaged in scientific and technological pursuit.